Welcome to The Explainer. Today, we're diving into the protocol that gives AI its hands and eyes, the thing that lets it actually interact with the world. And we're going to uncover how this incredibly powerful standard also opens up a whole new world of risk.
So let's start with a really fundamental problem. We all know AI models are incredibly smart, right? But on their own, they're kind of like a brain in a jar. They can think, they can process, they can generate text, but they can't actually access new information or take any action in the real world.
So, to be truly useful, these models need what we call tools. These are basically external functions that act as their eyes to see the world and their hands to, well, get things done.
Think of tools just like the apps on your smartphone. I mean, your phone's operating system is the core brain, sure, but it's the apps that let you check the weather, or send an email, or book a flight. For an AI, tools are its apps. They let that core intelligence do so much more than just spit out text.
Okay, so tools are great. We need them. But what happens when you're a big company and you've got dozens of different AI models and you want to connect them to hundreds of different tools? We're talking databases, calendars, internal software, you name it.
Well, you end up with something that developers call an integration nightmare. The more formal term for it is the N by M problem. And trust me, it's a recipe for absolute chaos.
Here's what that mess looks like. For every single model you have, that's your N, you need to build a custom one-off connector for every single tool, that's your M. The number of these unique connections just explodes exponentially. It becomes a completely unmanageable, expensive, and fragile system that is just impossible to scale.
So to solve this very real problem, the industry came together and in 2024 introduced an open standard called the Model Context Protocol, or MCP for short.
MCP is designed to be a kind of universal translator. The best analogy is probably a USB port for AI. Instead of needing 1,000 different plugs for 1,000 different devices, you just have one standard that works for everything. MCP creates that unified language, so any AI app can talk to any external tool, completely decoupling the AI brain from the tools it needs to use.
So how does it actually work? Well, the architecture is pretty slick. You have the host, which is the main AI application the user sees. Inside that is a client, which is like a little messenger, and that client talks to a server, which is where all the tools actually live. This separation is brilliant. It allows a whole ecosystem of specialized third-party tools to just plug right in.
Okay, now this is where things get really interesting. You see, the MCP standard actually defines a bunch of different capabilities. Things like tools, resources, and elicitation. But in practice, the industry has overwhelmingly adopted just one of them, tools. As you can see from this chart, support for everything else is, well, it's lagging way, way behind. Almost nobody is using it.
But here is the major twist. While MCP is this masterful solution to the integration problem, its open, dynamic, plug-and-play nature creates a brand new and, frankly, very dangerous threat landscape, especially for enterprises.
So the very features that make MCP so flexible also make it incredibly vulnerable. For instance, a server can dynamically inject a dangerous new tool without any warning. And if you load all the available tool descriptions into the AI's prompt, you bloat the context window, which drives up costs and can actually make the AI dumber. But the biggest issue? The base protocol just lacks the built-in security features, authentication, authorization, observability that big companies absolutely need. You have to remember it was designed for open innovation, not for airtight corporate security.
All right, let's make this concrete. We're going to look at a specific attack called tool shadowing. This is where a malicious tool basically hides in plain sight, and it's designed specifically to trick an AI into using it instead of a legitimate one. Okay, look at this. On the left, we have a perfectly legitimate tool for storing code in the company vault. Notice its description is very specific. But now look at the right, a malicious shadow tool. The name is kind of similar, but check out the description. It's way broader. It's designed to trigger on common words like save or store. An AI, just trying to be helpful, could easily get confused and send sensitive company data straight to an attacker's server instead of the secure vault.
But that's not even the scariest part. An even more insidious risk is a classic cybersecurity vulnerability known as the confused deputy problem, and it is particularly dangerous in the world of MCP.
So here's how the attack works. Step 1, an MCC server is set up with high-level admin privileges to a company's code repository. Step 2, an attacker who has very low privileges gives the AI a seemingly innocent prompt like, hey, find this secret file and make a public copy for me so I can review it. Step 3, the AI, which doesn't know any better, just sees a simple request and relays those commands to the super powerful MCC server. And here's the kill shot. Step 4, the server executes those commands using its own high-level permissions, not the low-level permissions of the user. And just like that, the secret code is leaked. The AI literally becomes an unwitting accomplice in the attack, and this quote on the slide just nails it. The attacker gets around all the security controls by exploiting the built-in trust between the AI and that powerful MCP server. The attack effectively turns an organization's own AI system against itself.
So if the protocol itself is this risky, how on earth are enterprises supposed to use it safely? I mean, is it even possible?
Well, the answer is that they don't really use the pure protocol. Instead, what they do is build a fortress of governance and control around it. This means using things like API gateways to inspect all the traffic, creating strict allow lists of only pre-approved tools, pinning tool definitions to specific versions so they can't be changed maliciously, and of course, for anything high risk, requiring a human in the loop to approve it.
And this really gets to the big takeaway. The future of enterprise AI isn't the wide open Wild West protocol itself, but rather these tightly controlled platforms that are built on top of it. MCP provides the common language, for sure, but the enterprise bears the full responsibility for building the secure, auditable framework to make it all work safely. So this leaves us with a really critical question for the future. As AI gets more and more autonomous, is this absolute need for security going to force all of this incredible open innovation back into a series of proprietary walled gardens? It really feels like we're in this constant race between AI's power to connect and our fundamental need to control it. Thanks for watching.